Hello and welcome, everyone. Happy Monday. We are really glad to have you here for the third session of our Day 1 and Beyond Security series. If you missed any of the previous sessions, you can find the recordings on the same Day 1 and Beyond page. And while you're there, please take a moment to review the other series and webinars that we have added for you. For those who are new, Day 1 and Beyond webinars are hosted on Cloud Customer Connect, which is our Oracle Community Forum for end users. If you have not already, I invite you to create a free account on Cloud Customer Connect, join in discussions, ask questions, and look for upcoming events on various topics. Our topic today is in the security session is Oracle Cloud Networking Foundations. My name is Renu Bhatt. I'm a program lead with the Customer Enablement team. And today I'm joined by Sean Moore, Principal Cloud Architect, and Ari Ateya, Senior Cloud Network Engineer here at Oracle. And what you see on the screen right now is the Day 1 and Beyond series that we have right now. So go ahead and check those links out later when you get the deck. Or you can, if you have the link to the main Day 1 and Beyond page, you can go to these series from there as well. And with that, please enjoy the session. Sean, please take it forward.
Okay, thank you so much, Renu. Welcome everyone to today's session. So my name is Sean Moore. I'm one of the many principal cloud network architects here at Oracle. And also joined with us today, my colleagues, Adi Ateya and Rafi Shabazian. And our team's goal today is to help our customers understand, implement, and support the wide range of networking features we have in OCI. So today we're going to cover the OCI network foundations to help you get started with building essentially the initial networking constructs to support your future workloads in OCI. And as we go through it, one of the important things to note is that correctly architecting and deploying these constructs, they're instrumental for building the framework needed to not only ensure expected network performance, reliability, but also it ensures a proper security parameter that's deployed to use network segmentation and access rules within OCI. Okay, so with today's agenda, we're going to essentially start off with a quick overview of regions and VCNs. Then I'll hand it over to Addy to cover gateways and VCN security constructs. And we'll wrap that up with a live demo. And then along the way, if any Q&A, any questions you have, again, place them in the Q&A section, or we'll kind of go through a few at the end of the session today. Okay, so with that, let's get started. So we're going to start off with regions, availability domains, and fault domains. So starting with regions, we essentially have a global footprint. And what we call our regions, we have more than 66 or 66 regions available as of today. We're constantly building new regions as we go along. And our goal is essentially to offer proximity to meet data requirements. That's either within region or within country as needed, along with providing true DR with distributed cloud regions in essentially every country is a game plan. So Oracle has a unique offering of regions. So not only do we have a footprint in multiple areas around the world, but we also offer solutions such as dedicated region cloud to customer, where we bring all of our cloud services directly to you on-prem. And we also have partnerships with other cloud providers like Microsoft to do things such as directly interconnecting our data centers with theirs to ensure we have that multi-cloud capability without having to go through multiple third-party vendors as well. So what's within inside a region? Essentially, we have what we call our availability domains. So these are built essentially for high availability, and they're really independent data centers. It can either be a physical building, it could be a campus with buildings, but in either case, these ADs, as we call them, are always in close proximity of each other if they're multiple within a region. And along with that, these ADs, they have a requirement. So essentially, if we have ADs within a region, we require that they have low latency between each other. And these low latency connections are always lower than 500 microseconds or less of latency, and they're always encrypted as well. The purpose of these ADs is essentially high availability. So instead of having your resources located in one data center, we make sure that we have the capability to spread those across multiple data centers. And for those regions that's only located with one AD, we do offer something called a fault domain as well. So these fault domains, whether it's in a region with multiple ADs or one AD, these fault domains are essentially data center racks that's all grouped together. And this provides an additional level of high availability as well, because we group infrastructure, power, and we all make sure that this is segmented. So in case one fault domain goes down, we still have the other ones available. So when you think about these things, when you place your resources out across a region or even within an AD, you want to make sure that you spread your resources across these different segmented units where possible, just to ensure you have a zero data loss architecture, essentially. Take advantage of that high availability that we natively provide you. Okay, so that was the physical portion, essentially, of the network constructs we're going to talk to you today. Now, going forward, we're going to talk to you about the logical constructs, starting with what we call our virtual cloud network. Okay, so what is a virtual cloud network? Well, it's essentially just a software-defined version of your traditional physical network that you're used to in enterprise. This includes things such as subnets, route tables, gateways, and it sits within OCI, and this is where you place your OCI IS resources, which are provisioned with their own IP addresses. So these VCNs, they always exist within one region, but they can spread across multiple availability domains for high availability. And this VCN essentially covers a single contiguous IPv4 or IPv6 CIDR block of your choice. Now, the allowable VCN range for CIDR block range for IPv4 it could be as high as a /16 or as small as a /30. And with that, we always recommend that you make use of the private RFC 1918 address space. And then another recommendation is always to make sure it's non-overlapping with any other VCN or any other private network, whether that's on-prem or another cloud provider or even another region. Making these non-overlapping will always make your life easier as you scale for growth. Okay, so within the VCN, we have different networking constructs that, again, are the basic building blocks to ensure that you have a good design approach as you start deploying resources. So with that, we have things starting with the subnet, and this is essentially just the unit of configuration that's used to actually host your IS resources. And within the subnet, we have what's called a route table, which defines path and destinations outside the VCN, along with DHCP options, which allows you to specify things such as TFTP servers, DNS servers, and FQDN search domains. And we also have what's called security lists that provides ingress and egress firewall rules for the entire subnet. And right below that, we have what we call network security groups, which is another type of access policy within the VCN. It works just like the security list, essentially, but it applies directly to the resources VNet. And with this, Addie will discuss that as we go along here. Okay, so I'm going to drill in a bit deeper. So again, subnet is that unit that essentially is where your host resources will always be located. So with that, you will carve out essentially a CIDR block from the main VCN CIDR block. And the subnet always reserves the first two IP addresses from that CIDR block. The first IP address is the network address. The second address is your gateway. And then we also reserve the last IP address as well. And this is your broadcast address. So keep that in mind as you build these out. Essentially, we'll always take away 3 of those IPs for use for the network itself. Now, a subnet can be AD specific or it can be a regional subnet. So that's something to note. That's what makes us quite a bit different from other CSPs. Is that essentially out of the box, we like to make sure that we have HA everywhere we can. So with a availability domain, multiple availability domains within a region, with the regional subnet, you can deploy resources essentially within the same subnet, but in different physical ADs. Now note that these subnets, as they sit here, they cannot overlap with each other than the VCN itself. So the subnet, again, this is where your resources are deployed. This is where the withdraw their internal IP address, and it'll also make use of those DHCP services I mentioned on the other slide. So if you have like custom DNS servers, DHCP addresses, they'll all be pulled from what's assigned to the subnet itself. One other thing to note is that the subnets can be designated as either a private subnet or a public subnet, and we're going to talk about those nets. But before we do that, I do want to call out the route table. So with the subnet, we want to ensure that we have it regionally available if possible. That's a recommendation. But to send traffic outside of it, we have to use what's called a route table. So every subnet can be assigned with a single route table. And this route table, even though it's assigned, can only be a subnet can only be assigned to one route table. A route table can be assigned to multiple subnets. So keep that in mind as you're designing your architecture, that you can build one route table and have multiple subnets use it, or vice versa. You can have a route table dedicated per subnet. Now, when you deploy your VCN, you'll always be provided with the default route table, and this route table is always empty. But again, likewise, you can make use of the custom route tables to design out your routes in and out the subnet as needed. So with the route table, essentially what this is used for is sending, again, traffic outside a subnet by using what we call route targets, which is just the net top or where to go outside the subnet. And so you can designate things such as a gateway, which Addy will discuss, or even other things like a private IP address. So say you have like a firewall within this VCN, instead of going directly out to the internet or where have you, you can have your firewall inspect this traffic beforehand before it makes a decision on what to do with it. One thing to note is that with the route table, no routes are needed for the subnets within the VCN to communicate with each other. So if you have 5 subnets and essentially a route table with nothing in it, this inherently they can still communicate to each other by routing without any routes needed. And in fact, if you try to add a route, it really will not do much for you between those subnets. Okay, so now we talked about the differences between the public and private subnets. And then there's really just one major difference. So the difference is a public subnet allows resources within the subnet to have direct bidirectional internet communication. What this means is that if you have a resource, say in subnet B, that needs to talk to the outside world, you can do that via what we call an internet gateway. Vice versa, if you have an external resource that needs to communicate directly to, say, the VM inside subnet B, it can initiate a connection back in to that public subnet. Vice versa, the private subnet, this is really a one-way communication when it comes to initiating connectivity to the internet. And what does that mean? Subnet A, in this case, is a private subnet. This resource can initiate a connection out still, just like a public subnet. And communication can come back in via things such as NAT gateway, or we can use either a dynamic routing gateway to use like an on-prem internet service, or even your own NAT host. Or on top of that, we can specify that there is no internet access. So there's an option. But the thing to note is that a resource in the outside world on the internet cannot initiate a connection inbound to a private subnet. That is not allowed. That's very important to note when it comes to network segregation. When you have things such as databases or just those resources you do not want to have that exposed to the world, your private subnets is the way to go for additional layer of security. All right, so something that is very beneficial to be aware of is essentially resources, especially things such as your VM instances, where if it's a Linux or Windows, makes use of what's called a VNIC. This is a virtual network interface. And this interface is what sits inside the subnet, and this is what gets assigned its IP address. So when you provision an instance, it's always provisioned with what's called a primary VNIC. This primary VNIC is always has to be a part of a particular subnet. It could be a private IP address. It could also have a public IP address assigned to it. However, that's not the only VNIC you can assign. You can assign multiple VNICs to an instance. And now these VNICs that are assigned can either sit within the same subnet, or as it's shown here, you can actually provision additional VNICs in different subnets for different, most likely security postures or different workflows needed. Now, on top of additional VNICs that's provisioned within different subnets, you can take that a step further. You can actually deploy VNICs into different subnets and different VCNs. So say you have a firewall in the middle here, VM3, and you can not only accept traffic workloads from subnet B, but you can accept it from subnet X as well. Okay, so I mentioned this briefly, but each instance has the capability, if they're part of a what's called that public subnet, to be assigned with a public IP address. So this public IP address, IPv4 address, and is reachable directly from the internet. This address can be assigned to resources such as instances, load balancers, network load balancers. But essentially, to make use of this public IP, again, it has to be in a public subnet, and then you need to use we call internet gateway. Addie will explain that shortly, to make use and reachability to them. Now, there's two different types of IPs, public IPs. We have what we call ephemeral and reserved. So ephemeral IPs, these are essentially just temporary public IPs that are assigned for the lifetime of the instance. So when you deploy an instance within OCI, you assign it a public IP address. This IP address will stay with the instance no matter if it's turned on or off. However, once you terminate the instance, the IP address is gone forever. It's no longer available for use within your tenancy. Now you take this with what we call our reserved public IP addresses, and this becomes a part of what we call your OCI IP address pool. So in the same example, if you have the instance deployed, again, you can assign a public IP address to it. These IPs will persist whether the instance is turned on or off. But once you terminate the instance, this public IP address doesn't disappear from your tenancy. Instead, this IP address is moved back to what we call, again, that OCI public IP address pool. And with this, you can actually reassign that IP address to a different instance or different resource within your tenancy. One last thing to point out is that we do not charge for any of our public IP addresses, no matter if they're ephemeral, of reserved, or they're just unallocated reserve IP sitting in your IP pool. That can be very, very beneficial if that's something you make use of a lot. All right, so we covered the VCN constructs, and now I will hand it over to Addie to discuss gateways and our VCN security constructs.
Thank you, Sean. Hello, everyone. My name is Ati Atai, a senior cloud network engineer here at Oracle. Today, I'm excited to dive into the world of OCI gateway types and discuss the crucial security aspect of this concept. And later on, I will pass the torch to Sean for a live demo, but let's embark on this journey together into the OCI gateway and security. As you might know, a gateway is a network component that allows data to flow from one network to another. And gateways serve as a network entry and exit points, as all data outside the network must pass through it, basically. Here we have a quick intro of each gateway. Let's start with the Internet Gateway. Next, we will explain NAT, DRG, and Service Gateway. And we will continue this with peering gateways in OCI. The OCI Internet Gateway. So Internet Gateway will give bi-directional connectivity. So we could egress out of the cloud infrastructure towards the Internet. Likewise, we can connect back onto the public IP of a given instance in a public subnet to manage the compute instances like SSH connection request. There are some key points to consider. Resources that need to connect to internet must be in a public subnet and have a public IP address. And also each public subnet that needs to use the internet gateway must have a route table rules that specifies the internet gateways as a target and specifies security rules to control the types of traffic allowed in and out of resources in that subnet. And also a VPN can be attached to only one internet gateway at a time. OCI NAT gateway. The NAT gateways, on the other hand, only enable outbound connections to the private subnets, like perform patches or updates or just resources need general internet connectivity outbound. There are also some key points here to consider. NAT gateway is added to give instances a private subnet access to the internet. With the NAT gateway, these instances can initiate connections to the internet and receive responses, but they cannot receive any incoming connections initiated from the internet. And NAT gateways are highly available and support TCP, UDP, and ICMP ping traffic. Let's move to service gateway. Service gateway allows resources within our virtual cloud network to access public OCI services, such as object storage, but without using the internet or NAT gateway. So basically, your traffic will stay on the Oracle backbone, and the primary use case here is for database backups to object storage. OCI Dynamic Routing Gateway, or DRG. How we manage the customer on-prem traffic differs, and we handle that traffic with DRG. A dynamic routing gateway connects on-prem networks to VCN, and a DRG provides a single point of entry for remote network paths coming into the VCN. Basically, it provides the path for VCNs to communicate on-prem across regions or outside the regions, and each VCN can have a single DRG. About the use cases of DRG, I can say a DRG used while connecting from on-prem environment to the VCN using any one or both of IPsec VPN connections or fast connect connections. And a DRG is also used while peering two VCNs in different regions. We call it here remote VCN peering. The latest version of DRG is DRG version 2, and it's also known as a transit hub. And DRG also supports BGP routing and advertise all CIDRs for subnets created in the VCN routes via BGP into the route table assigned to the DRG. With DRG, everything works as an attachment theme. So we have VCN attachment, remote peering connection attachments, IPsec, and virtual circuit attachments. And this allows us to have a global network within OCI, scalable, and even more remote connectivity to DRG connections. And also we can have up to 300 VCNs attachment to this DRG. The good thing is that they do not have to be in the same tenancy. And we can also assign a different route table and policy to each network and resources attached to the DRG. Let's talk about the OCI gateway peering types. About the peering, we have a local and remote peering gateways. So local peering will connect to virtual cloud networks within the same region so that their resources can communicate using private IP addresses. Please keep in mind that the two VCNs in the peering relationship should not have overlapping CIDRs because an LPG is aware of the CIDR basically for the VCN it is attached to. However, if you want to leverage our local peering gateway to peer to different virtual cloud networks within different regions, you will use DRG and RPC, or remote peering connection. This is the process of connecting two virtual cloud networks in different regions so that their resources can communicate using private IP addresses. And also, like the LPG connections, the two VCNs in the peering relationship in RPC must not have overlapping CIDRs here. Perfect. Now let's talk about the VCN security. The OCI networking service offers two virtual firewall features that both use security rules to control traffic at the packet level. The two features are security list and network security group. A security list, which we have it in the slide, is a regional entity that acts as a virtual firewall for a compute instance with ingress and egress rules that specify the types of traffic allowed inbound and outbound. And subnets will be associated with security lists here, and essentially security lists are stateful. And stateful is what we allow in, we must explicitly allow also out. So we have ingress and egress components to the VCN security list in this case. So, however, on the other hand, security groups apply to VNICs of resources deployed within OCI, which are used for a group of nodes or group of VNICs with the same type of security. Thus, they can be grouped into network security group. And currently, compute instances, load balancers, database systems, ADB, mount targets, and DNS resolvers endpoints supports the use of a network security group or NSG. As I said earlier, security lists provide comprehensive security to application with rules for every subnet. But when multiple resources require different security postures within a subnet, you need to control the traffic at the more granular applications level. In that case, you can create those rules and add multiple resources using network security group. Yes, in continuing to the network security features, I can say the network security group or NSG and security list work in conjunction. Essentially, they are the union of the two. However, for a comparison of NSG and security list, I can say security list and network security group have distinct functions. Security list or SL applies security rules to all VNICs in a subnet. In contrast, a network security group or NSG applies a set of security rules to a specific group of VNICs chosen by you. And one unique feature of NSG or network security group is that their security rules only apply to the resources within that network security group. On the other hand, security rules have a broader reach as their rules apply to all resources in a subnet that use the list or that list basically. And the NSGs consist of ingress and egress security rules that apply only to a set of VNICs of your choice in a single VCN. Unlike the security list, the VCN doesn't have a default network security group when we create it by default. So you need also the NSGs you created are initially empty and they have no default security rules there, and you have to create it. And Sean, we will demo you later, about this security list and security group. Let's talk about one of the resources under the network command center. We call it network virtualizer. And the network virtualizer basically provides a diagram of the implemented topology of all VCNs in a selected region and tenancy. It can provide two level of views. Just one is a regional network topology. The other one is cloud network topology. With regional network topology, you can see a high level layout and routing topology of your entire virtual network configurations within a region. And this topology includes DRGs, VCNs, CPEs, and various types of gateways. with cloud network topology, you can see the organizations of a single VPN, including its subnets, routing configuration, security configuration associated to each subnet. And this topology includes subnets, VLANs, and gateways to all other resources there. And the last thing I can say about the network virtualizer is this feature is now available in all OCI regions. Okay, let's hand it over to Sean for a quick demo. Thank you very much for listening to me, everyone.
Thanks so much, Addy. Okay, before we demo, I will go over the use case. So essentially, we discussed, believe it or not, all the components necessary to build out what we like to call a three-tier architecture design, network design at least. Where in this case, you have maybe a public-facing website that you need to make visible to external parties, but at the same time, you need to keep those backends segmented and not accessible from the same external external parties. So in this use case, we have a internet-facing customer that's going to come through Internet Gateway. And with this, they'll hit what we call a public subnet. This public subnet we can deploy things such as the load balancer. And this load balancer can then route to a backend sets with backends with things such as an application service. And this application service that's sitting in a private subnet with the use of route tables can make a connection to some of our Oracle backend services such as object storage or autonomous database. Now for this demo, I'm going to essentially deploy all the network components, and maybe if I have some time, I can actually deploy a VM, but the focus is going to be on all the things we discussed today. So with that said, I'm going to briefly stop sharing and bring up the OCI console. All right, sharing my screen once again, and we are back. All right, so I'm in the Oracle console. First thing to notice, this is the dashboard essentially, or the kind of the get started page. But notice the region I'm in. I picked Toronto. Again, we have many regions available. But what I want to do is I want to essentially deploy this three-tier use case that we just discussed. So the first thing I'm going to do is I went to the top left hamburger menu, and I'm going to go down to networking here, and I'm going to go to virtual cloud networks. If you recall, this is essentially one of the first building blocks you need to actually deploy your resources. This is like having essentially a remote site extension of your own enterprise, which is on CIDR block, subnets, DHCP options, all that good stuff. So for this use case, we can actually deploy this either two ways. We can do it manually, or we can use what we call our VCN wizard. So I'm going to go to VCN wizard approach, and I will tell you why. So with our VCN widget, we have two options. The first is essentially to deploy a VCN with internet connectivity. That sounds promising. We can also extend that. We can have a VCN wizard also deploy site-to-site VPN connection as well. So I'm going to actually go with, that's the first option, a VCN with internet connectivity, because with this wizard option, we actually have a perfect template for a three-tier architecture. And I'll go through this now. So I'm going to hit the Start VCN wizard. Now, when you go through this wizard, there's really just two steps. The first step is just to give your VCN a name. I'm going to do that now. We call it Demo VCN. We have what's called compartments. That's essentially how you logically group all your light constructs together within OCI. Now, within a VCN, if you remember, we need a CIDR block for the VCN, and it should not overlap anywhere else. I'm going to use the default. It's a /16, probably bigger than what we need, but it's fine for the demo. But along with the VCN, we have what we call our subnets. So our subnets is where our resources are deployed into. Now, with this wizard, they will build out two subnets for us. One publicly facing, call our public subnet. Again, they carved out a CIDR block. It's always carved out from the VCN itself. And I'm also going to have a private subnet provisioned for me as well. So this private subnet also has its own CIDR block. Again, non-overlapping, but it's carved out from the VCN. So we're going to have a public subnet where we can deploy like a public load balancer. And we're also going to have a private subnet where we can even deploy an application VM if you want it. So I'm going to hit the next option. So the second thing is essentially just reviewing what we're going to do. So again, here's our name of the VCN that I put down there, tag, CIDR blocks. What I want to point out that's very interesting is essentially for subnets, or one thing is the gateways. So here's the gateway that's going to be provisioned for us right away with this wizard. We're going to have an internet gateway for that bidirectional communication. We're going to have a NAT gateway for that private subnet communication to initiate connections out for things such as updates, things of that nature, like Addy mentioned. And we'll also have a service gateway. And this is how we connect to our backend Oracle services, such as object storage or things like autonomous database. Along with the gateways, this wizard is going to create two separate security lists for us. One called default security list. Note the rules that's being built out here. Just a couple of ingress rules, few ingress rules. One allowing traffic in over port 22, SSH essentially, and some ping type traffic. And then also note that there is an ingress rule for the VCN itself. So one thing to note is that OCI, we essentially function on a zero trust architecture. So even if you have one subnet with multiple resources inside of the same subnet, those resources can't by default communicate to each other due to the zero trust nature of it. You have to specifically allow that communication between the two. Even though they can route to each other, they cannot communicate with each other. And that's the same thing for anything with that inside the VCN. So if you have multiple subnets, remember, you don't have to create a route rule for those subnets. However, you will need those security rules to allow that communication to actually be allowed. Okay, so with the second security list, that's going to be provisioned for us. It's going to be for the private subnet. Notice right away that it's a bit more restricted. So instead of allowing that any quad zero to access SSH connections, we're going to narrow that scope down to just the VCN itself. Similar for our route tables, note that there's a default route table. This one just has the default rule destination. It says to get out to the outside world. Your path is the internet gateway. We have one that will be deployed to the route, for the private subnet. Similar rule. To get out to the outside world, your only option is this NAT gateway. Anything else like Oracle Services Networks, object storage, autonomous database, we're gonna take the service gateway to get there. All right, so with that, I'm going to hit the create button. We're going to give it less than 20 seconds here. See the timing's good on that. And we're done. I think that was less than 20 seconds. Okay, so we have a VCN provision. So I'm going to hit the view VCN. Notice right away, it takes us right inside the VCN. You can also search for this here or go to the hamburger menu to find the VCN section. But remember, here's our CIDR block. Here are our two subnets down here. /24, one is public, one is private. If I go down the left side here, note that we have things such as the internet gateways. We have our other gateway options, local peering gateways, NAT gateways, service gateways. These are all the VCN gateways available. The DRG sits outside the VCN itself, but you can attach to it to get to other private networks outside the VCN. I will now open, essentially, let's open two new tabs here. Okay, let's take a look at both subnets in depth a bit. So I'm in the public subnet now. Again, here's the CIDR block for that. I notice that the route table is this default route table. Let's take a look at that. This is the one that we went through the wizard. This is the route rule that is being applied to the public subnet. So remember, each subnet can only have one route table assigned to it, but I could assign this route table to multiple subnets. But in this case, the public subnet has internet access via the internet gateway. Now, if I go back and if I look at the security list applied to it, you can have multiple apply it. Right now we have the one. I click on the security list. It applies for the entire subnet. And here's our ingress rules that we looked at a bit ago. Here's that quad 0 any rule essentially that allows SSH or port 22 access in. And if I go back here, if I compare that to the private subnet, we'll see things that's a bit different. First thing to note, again, this is a different CIDR block. So two separate subnets for segmentation purposes. This is really where you start to lay that security framework, because we're helping create walled gardens essentially to circumvent our attackers just from gaining access to our most critical workloads. But on top of that, we have two different type of routing and security list postures. So if I take a look at the route table, note that we still have a way to get out to the outside world, but this time it is our NAT gateway. Again, our NAT gateway allows us to make communications to the outside world, but it does prevent the outside world from initiating connections back inside to us. So if I were to deploy my application server here, I would be confident knowing that the outside world does not have a way easily inside to my network right here. Likewise, if I want to get access to some backend services from a 3-tier design, in this case, like a database, autonomous database, I have connectivity to it without ever going over the internet by making use of the service gateway. So this service label here is what this destination means. It's essentially all of our SaaS public network ranges. Allows me to connect directly to the autonomous database network via the service gateway. Okay. So believe it or not, we have our 3-tier architecture ready to go. The one last thing I want to show is the network visualizer. So if we go back to the top left-hand burger menu, networking, under the network command center, we have our network visualizer. So if you call from ADI, this gives you like that one place to view of all Oracle network resources within the region. And we'll just go over what I built so far. So right now I have just that VCN that I built using the VCN wizard. And so it brings me to this page here. Now this blue hexagon is the VCN. And if I click on it on the right side, I get a bit of a nice summary of what's going on with the VCN. If I take that a step further, notice that we have these circles here. These represent the gateways that's built out that we provision within the VCN itself. And if I had anything else like a DRG or other VCNs, that would show up here in this visualizer. Now to take it a step further, we can actually drill into what's going on inside the VCN by looking at what's called the VCN routing map or security map. I'll start with the routing map on the bottom right here. Give it a few seconds to load. All right. So essentially we have the shaded blue area. This represents your VCN. The VCN itself is going to show you all your subnets that you have provisioned, which are these little rectangles here. So if I'm looking at this, I have my private subnet up there, my public subnet down here. Now I'm going to scroll out just a bit, kind of maybe come back in again. Now within this visualizer, notice that when I click on both subnets, I get these highlighted blue lines here. And these lines represents the actual routes that the subnet is aware of and the net top out. So if I look at this private subnet, note that I have this default route. If you recall, that's essentially a line going out towards the NAT gateway. So this can be very helpful just for understanding exactly what your subnets are doing and where they're going. And to add on to that, we have what's called a subnet security map. So I'm going to switch over to that now. And it looks very similar, but in this case, it shows us just exactly that. It shows us all the security networking constructs we have within the VCN. So remember that there's essentially two networking constructs. There is the security list that applies to the entire subnet, and then we have network security groups shown here on the right that applies to the VNIC of a resource itself. We don't have any resources deployed at the moment within the subnet, so there's nothing there on the right side. But if I look back on the left side, if I click on this private subnet here, notice the dashed line goes over to the security list that's currently applied. Now, if I have multiple security lists within the subnet, we would see those here as well. One last thing to show is if I hit this view resource security details, from this single pane of glass, I can see exactly what rules are being applied to that subnet. Okay. So that really concludes the demo. We have our 3-tier architecture, and we also reviewed, along with that, that we can have a bird's eye view on what's going on with inside our OCI network. Some good things to know about. We have a really good certification program. And by what I mean really good is that they're constantly being added to, and they cover a lot of different areas. So one thing that we kind of recommend for a lot of our customers is try to just go through our learning path program available at Oracle University. We have things such as associate and professional levels architectural certs, along with a very new network professional certification that is very in-depth. And going through that, you will really get a great understanding of what's possible within OCI, how to troubleshoot, how to manage all those good things. And a lot of this is available free for you to just log in and go through it, whether you take the cert or not. So that's a good place to start. On top of that, we have additional resources. So besides just our public documentation, on how to configure, build things, we also have a huge blog page that myself, my colleagues, Rafi, Addy, we all contribute to that covers either everything from, the basic level network foundation stuff we presented today to one of those, corner cases or scenarios that, you see every once in a while, but hasn't really been shown to everyone. So that's a good place to look as well. We also have pages that go over things such as our network limits, like how many VCNs can you provision within a tenancy, or things such as how many gateways can you have within a VCN. Along with our reference architectures page is also another really good one, just to go through some either use cases, kind of like what I presented today, or some real life example of customers that have provisioned and moved their architectures from wherever they were to OCI or even greenfield use cases. And it's a very useful resource as well. So this is a good place to start.
Avinash is asking, is egress traffic outside traffic? And so egress traffic is essentially traffic that's initiated from a compute instance within the OCI VCN towards the internet. Now, this can be using either a NAT gateway or an internet gateway, as well as egress traffic is anything towards a remote OCI region as well. So across an RPC, right? So to a local or remote region. So anything that's egressing out of your VCN towards either an internet or an OCI region will be considered egress traffic. This is in regards to, I assume, the billing pricing question, what's considered egress traffic.
Thanks, Rafi. Okay. Just going down the list here. I see there's a question you answered earlier about are availability zones interconnected? Yes, within the region. Yep. So if you have a region that has multiple availability domains, they're always connected. They're always low latency. By low latency, we mean under 500 microseconds or less is their target, and it's always encrypted between them. Now, just the follow-up question, are FDs only available if there's only one AD in a region? No, every AD has fault domains. So no matter if you're in a multi AD region or a region with just one AD, you can always make use of a fault domains, and we have a lot of customers that do that.
And Sean, there's a new one that just came in from Peter. Is there default logging of blocked traffic by security lists, and is it searchable? So this is a really good question. So by default, we explicitly allow traffic on security lists, else it's implied, implicitly denied. So whatever we don't explicitly define in there is going to be denied by default. However, is it searchable? Not by default. So what we need to do, Peter, in this case is for a specific security list that's associated with a given subnet, we'd need to go to the subnet. We'd have to enable the VCN flow logs, which is turned off by default. But once you enable the VCN flow logs, then what we'll start seeing under the logs are rejects for anything that is making it to the subnet, but is being rejected by the security list.
Can LPG be attached to a DRG? And thanks, Rafi, answer that one. Yeah, you cannot. So LPGs is really just for the VCN to VCN communication. What you can do if you need VCNs to communicate is this is what we recommend. Honestly, purely, well, I'll say mostly from a scalability point, is to use a DRG attachment for all your VCNs to a DRG. That allows you to not only just have better management of interconnecting between multiple VCNs, but there's also a limitation with LPGs. So with LPGs, you can only attach up to 10 to a VCN. So that you can hit that limit fairly quickly. And essentially, when you're designing LPGs, you kind of have to make a mesh network if you start to scale past essentially more than 3 VCNs. So our recommendation is always a DRG for the type of scalability. Would it be possible to use case to find more than one NAT gateway VCN? Oh, thanks, Raf. You answer that as well. Yep. So you can't have multiple NAT gateways if, for whatever reason, we run into what's called port exhaustion, TCP port exhaustion issues. It's a common networking thing. It's not just an OCI thing. In that use case, yes, you can make use of multiple NAT gateways within a VCN.
There was another one I think it was really interesting. Samrat had asked about does, in a hub and spoke architecture, does it have to be a network firewall in order for, say, traffic to transit out through and hit the internet? And yeah, we did answer that, but just for everybody's knowledge, no, it does not have to be a network firewall, right? Linux instances performing IP tables using masquerading, can be used in lieu of a network firewall. So I thought that was a really interesting question. So thanks for
it was. That's a great question. But we have our documentation resource within OCI, but I think each source like Terraform actually has a lot of our code as well that you can use to help kind of guide you on building the infrastructure as code. But we definitely have a lot of resources out there for that.
And it's probably worth pointing out we do have our landing zone as well. That's in the GitHub repository where we can go essentially take that Terraform code and modify it to our heart's content, and add subnets, route tables, security lists, so on and so forth, and really automate the infrastructure as a service lifecycle for this. So yeah, a lot of options available there, Ramon.
Thank you, everyone. Great session, Sean and Ari and Rafi. Thank you so much for fielding all those questions. Really appreciate that. I'm sure everyone learned something new today. Our next session will be on Monday, April 15th, where we will cover OCI Network Firewall, which is a managed firewall service built using next generation firewall technology. You'll learn about how to apply granular security controls to inbound, outbound, and lateral traffic based on the multiple use cases and design patterns. So if you're interested, please do not forget to register for the session using the link that I just put in the chat. I recommend that you bookmark the Divan and Beyond page and check frequently for new sessions on trending topics. And thanks again for joining us. See you all next time. Have a great day, everyone.